Suburban Sentinel here, along with Bella the camera cat. Today doing part 2 of our 3-part series on magazines. In part 1 we covered the mechanics and the basic physics behind your typical box type removable magazine. And today we're going to examine 4 very popular magazine myths. I just want to reiterate my disclaimer. I am not a gun guru. I'm not a gun designer. I don't deem myself an expert in guns or anything else for that matter. All of my engineering experience comes out of the aerospace industry. Also, please note that I am not being critical of anyone who subscribes to any of these popular gun myths. Like any other good myth, there is an element of truth to each one we will be discussing. In addition, these myths have been repeated for so long and so often by supposed experts in the field, it is certainly understandable that these would be believed. So let's get down to business. Myth number 1. Leaving your magazines loaded for extended periods of time will weaken the spring and shorten the life of the magazine. Some gun enthusiasts recommend that, to the maximum extent possible, you leave and store your magazines empty, and that you periodically cycle your magazines from the loaded to unloaded condition. The most popular rationale for this recommendation is often called spring set. The theory is that a loaded magazine spring will take the set, or in other words, remain in the state of compression of the load that it's bearing. Now, spring set is a real metallurgical phenomenon. However, it's often misapplied to stand for the proposition that you should not leave your magazines loaded or cycle your magazines from loaded to unloaded conditions periodically. So let's get into this a little further. Again, spring set is real, but it occurs when a spring that is brand new is fully compressed for the first time or two. If you remember, in part 1 of this video, we discussed Hooke's law and elastic deformation versus plastic deformation and some of that other happiness. So how does this apply? If you take a brand new compression spring and impose a load upon the spring that compresses it down to the very top of the envelope of its design limits and then remove the load, you'll often see that the spring is shorter than before the load was applied. This is because the spring in its new condition is not 100% elastic at its maximum compression. After 1 or 2 applications of the maximum design load, the spring does take a set. However, subsequent loadings within the design limits will not result in any further appreciable spring set. So essentially, spring set is a one-time phenomenon. Note that design engineers know about the rates of initial spring sets given the material used and the application of the spring, and compensate for potential spring set in the design and manufacturing processes. I've heard many shooters say over the years that their magazines have taken a set to the loads imposed by keeping rounds in the magazine over a long period of time. In support of this assertion, they'll take springs from two identical magazines, one brand new and one that's been in service for several years, and the older magazine's spring will be substantially shorter than the new magazine's spring. But the assertion is misplaced. What the shooter perceives as spring set, the evidence being a shorter and or weaker spring, is actually a magazine spring that has failed or has been substantially weakened for other reasons. The failure is not attributable to leaving the magazine loaded within its design limits. Now you may say to yourself, this is all just semantics. Whether you call it spring set or failure doesn't really matter. And I would agree with that statement, but for one fact. Many of those who subscribe to the spring set theory concerning magazines also believe that spring set is a condition that can be remedied. Now this is where you can get into trouble, because you'll often hear these shooters say, well, rotate your loaded magazines, and by taking the stress off the spring and leaving the magazine unloaded for a few months, the magazine spring will heal itself, for lack of a better term. The truth is that a magazine spring that has either failed or has taken on an initial spring set will not just go back to its original form or shape by virtue of it being left unloaded for a long period of time. In addition, some shooters assert that what they believe is spring set can actually be remedied by taking the spring and physically stretching it out, like you were stretching your legs after a long airplane ride, and that will cure spring set. The bottom line is, though, it's not curing spring set at all. It's not curing anything. In fact, it's making the spring weaker. In part 3 of this video, hopefully by the end of the week, we'll cover maintenance of magazines in further depth. In conclusion, don't be afraid to store loaded magazines. As long as you have a well-designed and well-made magazine in good condition, if properly stored, it will not hurt the spring. So let's move on to myth number 2. You should download your magazine by a round or two to relieve spring pressure so that your magazine will last longer. So for example, if you have a 15-round magazine, the proponents of this theory say download it to 14 or 13 rounds. The most often cited rationale for this recommendation is called spring creep. Now, spring creep is real, but it's often misunderstood. And by the way, spring creep is not some weird little guy who comes around in April. Spring creep is a real metallurgical phenomenon in which a spring under a constant load that is well within its design limits will deteriorate even under static conditions over time. So the theory is that if I take this 10-round 308 magazine and only load it with 4 rounds and just leave it in a safe somewhere for 50 years, the magazine will deteriorate even though it's well within the spring compression design limits. Now that is technically true, so those who download their magazines appear to be justified in doing so. But here's the rub. The largest factor in determining spring creep is temperature. More specifically, the most important factor is ambient temperature compared to the melting point of the material the spring is made from. Spring creep really is an important engineering factor in applications where you're using soft metals with low melting points. It is also a significant factor in dealing with springs made out of more heat-resistant materials, but that are used in very hot operating environments, such as spacecraft or gas turbine engines. But gun magazine springs, such as any of the three you see here on the table, are made of durable steels, and the operating environment is generally room temperature up to very hot outside air temperatures. The accepted engineering rule of thumb is that spring creep becomes an important factor in operating environments where a sustained temperature is 30% or more of the spring material's melting point. As the melting point of spring steels used in your typical magazines starts somewhere around 750 to 800 degrees Fahrenheit, creep only becomes a significant factor at around 250 degrees Fahrenheit. And what do we mean by a significant factor? A spring is usually considered failed if it's a 1% or more plastic deformation. In other words, if it loses 1% or more of its elasticity. Since spring creep is real and it occurs at just about any temperature on any spring material, I went back and did the calculations on a typical gun magazine stored at about 100 degrees Fahrenheit to give you an idea of what type of spring creep you could expect. Now, I won't do the calculations on camera because it takes a long time and quite frankly it's kind of boring. But to achieve a 1% plastic deformation, which would be considered a failure in spring engineering, at 100 degrees Fahrenheit, the spring creep time requirement exceeds 1 million years. So if you plan on keeping your magazines for more than 1 million years, by all means go ahead and download them. In conclusion, if you have a well-designed and properly manufactured spring that is in otherwise good condition, downloading is simply unnecessary. So let's move on to myth number 3. You should always keep your magazines clean and well oiled to prevent corrosion and provide proper lubrication. The rationale is that your magazine is part of the gun and that it should be treated with the same care as all other parts of the gun. But note, this could get you killed. It certainly is a good practice to keep your magazine clean. And I'm talking about the internals of the magazine especially. But don't use gun oil on your magazines. Now, gun oil generally won't hurt the magazine, but it can compromise the integrity of or destroy your ammunition. So by using regular gun oil in and around your magazine, your weapon may be in great condition, but it won't fire because your ammunition has been compromised. Of course, you want to keep your magazines clean and provide anti-corrosion protection and lubrication, and there are safe ways to do it, but you don't want to use regular gun oil. And we'll get to that in magazine maintenance in part 3. So let's move on to our 4th and final myth in this series. Even with regular use, a clean and well-maintained magazine can last indefinitely. This is simply not true. Magazines are life-limited components that require periodic rebuild or replacement. Magazines such as these incur a phenomenon known as cycling fatigue. No matter how good the spring is or how well you take care of it, there's only a certain amount of times that this spring will go up and down and maintain its design limitations. As the number of cycles increases, the elastic nature of the magazine spring becomes more and more plastic. In other words, it loses its springiness over time. More accurately, it doesn't lose its quote-unquote springiness over time, it loses its springiness with the number of cycles. And we will discuss that more in depth in part 3 of this video series concerning magazine maintenance, because I think Bella is getting antsy. So we will pick all this up again in part 3. Thanks for watching on behalf of myself and Bella the camera cat. So class is dismissed, and shoot safely, everybody.